Let's get started with C#, one of the most versatile programming languages used for everything from desktop apps to games. C# is an object-oriented programming language developed by Microsoft. It's widely used in building Windows applications, games with Unity, and web applications using ASP.NET. C# offers both power and simplicity, making it ideal for beginners and experienced developers alike. Let's write our first C# program that prints "Hello World" to the console. You can use Visual Studio or a simple text editor with the .NET SDK installed. Here we're using console writeline to print to the console. The main method is the entry point of any C# program. Let's break down the basic syntax of C#. Classes. Everything in C# is encapsulated within classes. Methods, functions inside classes, are called methods, like the main method we just used. Variables and data types. Variables store data, and C# has strong types like int, string, and bool. This example shows how to declare variables and use them in a console.writeline statement. That's a quick introduction to C#. Stay tuned for more videos as we explore object-oriented programming, data types, and more advanced C# features. Let's explore the basic data types in C# and how you can use them in your programs. In C#, data types define the kind of data a variable can hold, such as numbers, text, or true-false values. Using the right data type ensures efficient memory usage and prevents errors. Here are some common data types in C#. Int, used for integers, whole numbers. Double, used for floating point numbers. Char represents a single character. String holds text, a sequence of characters. Bool represents true or false values. Let's see how to declare variables using these data types, assign values to them, and print them. In this example, we declared variables using different data types and printed them using console writeline. That's a quick overview of C# data types. Keep practicing with more examples and learn about type conversions and complex data structures like arrays and lists. Let's explore how to use variables and constants in C#, two fundamental concepts in programming. A variable is a named storage location in memory that holds a value. You can change its value throughout your program. Here's how to declare and initialize variables in C#. First, specify the data type, then give it a name and assign a value. In this example, we declare an integer for age, a string for name, and a double for price. A constant is a value that cannot be changed once it is assigned. Constants are useful for values that remain the same throughout your program, like mathematical constants or configuration values. To declare a constant in C#, use the keyword const. Unlike variables, constants like pi and max users cannot be reassigned after they are initialized. That's a quick overview of variables and constants in C#. Use variables for data that changes and constants for values that remain constant. Let's dive into C# operators and learn how to use them in your programs. Operators in C# allow you to perform operations on variables and values. They include arithmetic, comparison, and logical operators, which help control data and the flow of your program. First, let's look at arithmetic operators. You can use them for basic mathematical operations like addition, subtraction, multiplication, and division. Here we use the plus sign for addition, the minus sign for subtraction, the asterisk for multiplication, the forward slash for division, and the percent sign for the remainder of division, also known as modulus. Next, we have comparison operators. These help us compare two values and return a Boolean result of true or false. These operators include double equals for equals, exclamation mark equals for not equals, greater than, less than, greater than or equal to, and less than or equal to. Logical operators are used to combine multiple conditions. For example, the double ampersand operator checks if both conditions are true, while the double pipe symbol checks if at least one is true. The double ampersand, also known as and, returns true if both conditions are true. The double pipe, also known as or, returns true if at least one condition is true. The exclamation mark, also known as not, inverts the Boolean value. That's a quick overview of operators in C#. Keep practicing, and soon you'll master how to manipulate and compare values in your programs. Let's explore how to work with strings in C# and manipulate text in your programs. A string in C# is a sequence of characters enclosed in double quotes used to store text data. You can combine strings using concatenation or string interpolation. Concatenation is done using the plus sign, while interpolation uses curly braces inside a string prefixed with a $sign. Now let's look at some common string methods. Length, which gets the length of the string, to upper and to lower, which convert the string to uppercase or lowercase. Contains, which checks if the string contains a specific substring. Replace, which replaces characters or substrings. Substring, which extracts a portion of the string. You can format strings using string.format or interpolation for more control over your output. That's a quick look at working with strings in C#. Practice these methods, and you'll be able to manipulate and format text easily. Let's explore how to use if and else statements in C# to make decisions in your programs. Conditional statements in C# allow you to execute different blocks of code based on certain conditions. Here's a basic if statement. If the condition is true, the code inside the block will run. In this example, if the age is 18 or greater, the program will print, "You are an adult." You can add more conditions using else if and a default case with else. Here, depending on the value of age, the program will print different messages. You can also nest conditions inside other if statements or use comparison operators to make your conditions more complex. In this example, we check both the age and whether the user has an ID to determine access. That's how you can control program flow with if, and else in C#. Try practicing with different conditions to see how they work. Let's learn how to use the switch statement in C# to make your code cleaner and more efficient. A switch statement is an alternative to multiple if and else conditions. It allows you to evaluate a single expression and execute different code blocks based on the result. Here's a basic example of using switch to respond to different user roles. In this example, the switch statement checks the value of role and prints a message based on whether it's admin, user, or guest. The default case handles any values that don't match. Sometimes you may want multiple cases to share the same result. You can combine them like this. Here, cases 1, 2, and 3 share the same result, which is helpful for grouping similar conditions. That's how you use switch statements in C#. They make your code more readable when handling multiple conditions. Let's explore loops in C# and learn how to repeat tasks efficiently with for, while, and do-while loops. In programming, loops let us repeat a block of code multiple times until a condition is met. This reduces the need for repetitive code. First, let's look at the for loop. It's perfect when you know how many times you want the loop to run. In this example, the loop runs 5 times, printing the current value of I from 0 to 4. Next, we have the while loop. This runs as long as the condition remains true. In this example, the loop continues until the counter reaches 5. The do-while loop is similar to while, but it always executes the code at least once, regardless of the condition. Here, the loop runs once, even though the condition is false from the start. Be careful with loops. If the condition never becomes false, you can create an infinite loop. Use break to exit a loop when necessary. You can also use continue to skip to the next iteration. This skips the value 3, but continues with the rest of the loop. That's how you use loops in C#. Practice these to handle repetitive tasks in your programs. Let's learn about arrays in C#, one of the most useful data structures for storing collections of items. An array is a collection of elements of the same type stored in a fixed-size block of memory. You can use arrays to store multiple values in a single variable. Here's how to declare and initialize an array. Let's create an array of integers. You can also declare an array and assign values later. For example, creating an array that can hold 3 integers and then setting values for each position. Accessing an element in an array is simple. You use an index to refer to the position of the element. The first element is at index 0. In this example, we print the first number and the second age stored in our arrays. You can use loops to go through all elements of an array. Here's how you can use a for loop to iterate through each element. This will print each element in the array one by one. You can also modify the elements of an array. For example, updating the third element to a different value. This updates the third element in the array to the new value. That's how you work with arrays in C#. Try creating and manipulating your own arrays for practice. Let's dive into using lists in C#, a flexible alternative to arrays for managing collections of data. A list is a dynamic collection that can grow and shrink in size. It provides more functionality compared to arrays. To declare and initialize a list, you use the list class. For example, creating a list of numbers with initial values or starting with an empty list and adding items later. Adding and removing elements in a list is straightforward. For example, you can add an item to the end or remove the first occurrence of a specific item. Accessing and modifying elements is similar to arrays, but lists also provide extra methods for flexibility. For instance, printing the first element and then changing the second element to a new value. Here are some common list methods you might use, like checking if an item is in the list, sorting the list alphabetically, or reversing the order of elements. That's an overview of using lists in C#. Experiment with these features to better manage your collections of data. Let's explore dictionaries in C#, a powerful way to store data using key-value pairs. A dictionary is a collection that stores data in pairs, where each key is unique and maps to a value. It's ideal for scenarios where fast lookups are needed. To declare and initialize a dictionary, you use the dictionary class, where the key represents one type of data and the value is another. For example, creating a dictionary where names are keys and ages are values. Adding items to a dictionary is easy with the add method, and you can access items using the key. Here, we add a new entry and retrieve a value using a key. To remove an item, use the remove method. You can also check if a key exists using contains key. This removes an entry and checks for the presence of a key. To iterate through the dictionary, use a loop to access each key and its corresponding value. That's an overview of dictionaries in C#. They're perfect for efficient data lookups and management. Give them a try in your projects. Let's dive into methods in C#, a fundamental way to create reusable and organized code. A method is a block of code that performs a specific task. Methods help keep your code modular and reusable. Here's how to define a basic method. Let's create a method that prints a greeting. This method, greet, doesn't take any parameters and doesn't return a value. To use the method, you call it by its name followed by parentheses. Here we call the greet method to execute the code inside it. Methods can also take parameters and return values. Let's create a method that adds two numbers. The add method takes two parameters and returns their sum. We then print the result. That's a quick overview of methods in C#. Try creating and using your own methods to improve code reusability. Let's dive into method overloading in C#, a powerful feature that allows you to define multiple methods with the same name but different parameters. Method overloading is the ability to create multiple methods with the same name but different parameter lists. It improves code readability and usability. Here's a basic example of method overloading. We'll create two methods with the same name but different parameter lists. In this example, display is overloaded to handle both int and string parameters. Let's extend this with methods that have different numbers of parameters. Here, printinfo is overloaded to handle one or two parameters, demonstrating different parameter counts. Method overloading is useful for operations that can logically be performed with different types or numbers of inputs. For example, you might use method overloading to handle different types of data or to provide multiple ways to perform a task. That's a quick overview of method overloading in C#. Try overloading methods in your own code to make it more flexible and readable. Let's explore recursion in C#, a technique where methods call themselves to solve problems. Recursion is a programming technique where a method calls itself to solve smaller instances of the same problem. It's useful for problems that can be divided into similar subproblems. Here's a simple example of recursion. We'll write a method to calculate the factorial of a number. The factorial method calls itself with a decremented value until it reaches the base case. Base cases are crucial in recursion. They prevent infinite recursion by providing a condition to stop the recursive calls. In the factorial example, the base case is when n is less than or equal to 1. Let's look at another example, the Fibonacci sequence. Each number is the sum of the two preceding ones. The Fibonacci method calls itself twice to calculate the Fibonacci number for n. That's an introduction to recursion in C#. Try implementing your own recursive methods and see how they can simplify complex problems. Let's dive into classes and objects in C#, fundamental concepts in object-oriented programming. A class is a blueprint for creating objects. It defines the properties and methods that objects created from the class will have. Here's a simple class definition in C#. We'll create a person class with properties for name and age. This person class has properties for name and age, and a method called greet. To create an object from a class, you use the new keyword. Here's how to instantiate a person object. Here, we create a person object, set its properties, and call the greet method. Classes can have methods that define action. In the person class, the greet method prints a greeting using the object's properties. Methods can perform operations on the class's data or interact with other objects. Constructors are special methods that initialize objects. Here's how to add a constructor to the person class. Now, you can initialize a person object with specific values when you create it. That's an overview of classes and objects in C#. Experiment with creating your own classes and using them in your projects. Let's explore constructors in C#, a key feature for initializing objects with custom values. A constructor is a special method in a class that is called when an object is instantiated. It initializes the object state. A default constructor is one that takes no parameter. It's provided automatically if no constructors are defined. In this example, the default constructor sets default values for name and age. A parameterized constructor allows you to initialize an object with specific values. This constructor initializes the name and age properties with values provided when the object is created. You can overload constructors to provide different ways to initialize an object. Here, person has 3 constructors: a default constructor, a parameterized one, and one that initializes only the name. Constructors are used to ensure that objects are created in a valid state. They help set up initial values and can enforce certain rules. That's an overview of constructors in C#. Experiment with different types of constructors to get comfortable with initializing objects. Let's dive into inheritance in C#, a key concept in object-oriented programming that allows you to extend and reuse code. Inheritance allows one class to inherit the properties and methods of another class. This promotes code reuse and establishes a hierarchy. Here's how to create a base class and a derived class. We'll start with a vehicle base class and a car derived class. The car class inherits from the vehicle class and adds its own properties and methods. A derived class can access public and protected members of the base class. Here's how to use the car class. The car class can use the start method from the vehicle class and its own hunc method. You can also override methods in a derived class to provide specific implementations. Here's how to override a method. The car class overrides the start method to provide a custom message. You can use the base keyword to call the base class version of an overridden method. This allows you to extend the functionality of the base class method while preserving its original behavior. That's a quick overview of inheritance in C#. Practice using inheritance to create more modular and reusable code. Let's explore polymorphism in C#, a powerful concept in object-oriented programming that allows for flexible and reusable code. Polymorphism means many shapes. In programming, it allows methods to do different things based on the object it is acting upon. Compiled time polymorphism, or method overloading, occurs when multiple methods have the same name but different parameters. Here, the add method is overloaded to handle both integers and doubles. Runtime polymorphism, or method overriding, allows a derived class to provide a specific implementation of a method already defined in its base class. In this example, the speak method is overridden in both dog and cat classes. Using polymorphism, you can write code that interacts with objects of different classes through a common interface. Here, myAnimal can refer to objects of different types, and the appropriate speak method is called based on the actual object type. That's an overview of polymorphism in C#. Use polymorphism to create flexible and extensible code structures in your applications. Let's dive into abstraction in C#, a concept that helps in managing complexity by focusing on essential features and hiding implementation details. Abstraction allows you to define the structure of a class without specifying the exact implementation. It helps in simplifying complex systems by hiding unnecessary details. An abstract class cannot be instantiated directly. It can contain abstract methods, which must be implemented by derived classes. Here, shape is an abstract class with an abstract method calculate area and a concrete method display shape. A derived class must implement all abstract methods from the base abstract class. In the circle class, we provide a specific implementation for the calculate area method. Here's how you can use an abstract class and its derived class. Even though shape is abstract and cannot be instantiated, circle can be instantiated and used. That's a quick overview of abstraction in C#. Use abstract classes and methods to simplify complex systems and focus on what's important. Let's explore interfaces in C#, a key feature for defining contracts and ensuring consistency across different classes. An interface in C# defines a contract that classes can implement. It specifies methods and properties that a class must provide without defining how these methods and properties are implemented. Here's how to create an interface and implement it in a class. In this example, iDrawable is an interface with a draw method, and Circle implements this interface. A class can implement multiple interfaces, allowing it to fulfill multiple contracts. Here, Document implements both iDrawable and iPrintable interfaces, providing implementations exceptions for both draw and print methods. Interfaces can also inherit from other interfaces, allowing for more complex hierarchies. In this example, isShape inherits from iDrawable, and Rectangle implements isShape, providing both draw and area properties. That's a quick overview of interfaces in C#. Use them to create flexible and consistent designs across your application. Let's dive into encapsulation in C#, a fundamental concept in object-oriented programming that helps protect data and enhance flexibility. Encapsulation is the concept of wrapping data and methods that operate on the data into a single unit, typically a class. It helps control access and maintain the integrity of the data. C# provides access modifiers to control the visibility of class members. Common modifiers include public, private, protected, and internal. In this example, name is a private field, and setName and getName are public methods that provide controlled access to it. By using encapsulation, you hide the internal state of an object and only expose what is necessary through public methods or properties. Here we use setName and getName methods to interact with the name field, ensuring that any validation or business logic is encapsulated within the person class. Properties provide a more concise way to encapsulate fields and control access. They combine get and set methods into a single unit. In this example, salary has custom logic to prevent negative values, providing a cleaner and more maintainable way to handle data access. That's a quick overview of encapsulation in C#. Use it to protect your data and design robust and maintainable systems. Let's explore properties in C#, a powerful feature that simplifies data access and encapsulation in your classes. Properties in C# provide a way to read, write, or compute values of private fields through methods known as getters and setters, but they look like simple fields. Auto-implemented properties are used when you don't need any additional logic in the getter or setter. They simplify property declaration. Here, name and age are auto-implemented properties with no additional logic. The compiler automatically creates a private backing field for them. You can also include logic in the getter or setter of a property to control data access. In this example, the salary property has logic to prevent setting negative values. Read-only properties are used when you want to provide a value that can only be set during initialization or through a constructor. Here, width and height are read-only properties, and area is a computed property with no setter. That's a quick overview of properties in C#. Use them to simplify data management and improve encapsulation in your classes. Let's dive into static members in C#, which allow you to share data and methods across all instances of a class. Static members belong to the class itself rather than any particular instance. They are shared across all instances and are accessed directly from the class. Static fields are used to store data that is shared among all instances of a class. In this example, count is a static field that keeps track of how many counter instances have been created. Static methods are used to perform operations that don't rely on instance data. You can call add without creating an instance of methodals. Static properties provide a way to encapsulate static fields with additional logic. Here, connection string is a static property that manages a static field with getter and setter methods. That's a quick overview of static members in C#. Use them to share data and functionality across all instances of your classes. Let's explore namespaces in C#, a feature that helps organize your code and manage naming conflicts. A namespace is a container that holds classes, structs, enums, and other namespaces. It helps group related types together and prevents naming conflicts. You can define and use namespaces to organize your classes and other types. In this example, logger and data manager are in different namespaces, utilities, and data, respectively. Namespaces can be nested to create a more hierarchical organization. Here, service provider is in the nested namespace myapplication.services. Use the using directive to simplify access to types in a namespace. With using directives, you don't need to specify the full namespace path for logger and data manager. That's a quick overview of namespaces in C#. Use them to keep your code organized and avoid naming conflicts. Let's explore how to handle exceptions in C# to make your applications more robust and error-resistant. Exceptions are errors that occur during the execution of a program. They disrupt the normal flow of control and need to be managed properly. Here's how to use try, catch, and finally blocks for basic exception handling. The try block contains code that may throw an exception. The catch block handles specific or general exceptions, and finally runs code that should always execute, such as resource cleanup. You can create custom exceptions to provide more specific error information. Here, custom exception is a user-defined exception class that inherits from exception. Best practices for handling exceptions include logging errors, avoiding empty catch blocks, and using exceptions for exceptional conditions only. Always log exceptions for debugging and avoid swallowing exceptions without handling them properly. That's a quick overview of handling exceptions in C#. Use these techniques to improve your application's error management. Let's dive into custom exceptions in C#, allowing you to define your own exception types for clearer and more specific error handling. Custom exceptions help to represent specific error conditions unique to your application, making it easier to handle and debug issues. To create a custom exception, you inherit from the exception class and add any additional properties or methods as needed. Here, validation exception extends the exception class and includes an additional error code property for more detailed error information. Throw and catch custom exceptions to manage specific error scenarios in your code. In this example, validate input throws a validation exception if the input is invalid and the exception is caught and handled in the catch block. Best practices for custom exceptions include using meaningful names, adding useful properties, and avoiding using custom exceptions for control flow. Custom exceptions should be used for representing errors, not for regular control flow in your application. That's an overview of custom exceptions in C#. Use them to enhance your error handling and make your code more robust and maintainable. Let's explore how to handle null values and use nullable types in C# to manage cases where values may be absent. Null values represent the absence of a value and can cause runtime errors if not handled properly. Understanding how to manage null values is crucial for robust code. Nullable value types allow value types like int and double to represent an additional state, null. Use a question mark to make a value type nullable. Here, nullableInt and nullable can hold null values in addition to their usual values. To work with nullable types, you can use the hasValue property to check if a value is present and the value property to access the value. Here, hasValue checks if nullableInt contains a value and value accesses it. The null coalescing operator provides a default value if nullableInt is null. Best practices include using nullable types for optional data, handling null values carefully to avoid exceptions, and using default values where appropriate. Always check for null before accessing nullable types to prevent runtime errors. That's a quick overview of using null and nullable types in C#. Implement these techniques to handle absent values gracefully in your applications. Discover how lambda expressions in C# can help you write more concise and flexible code. A lambda expression is a way to create anonymous functions or methods in line. They're often used for short-lived operations. Here's the basic syntax of a lambda expression. For example, a lambda that adds two numbers looks like this. Lambdas are commonly used with linked queries to filter or transform data. Here's an example using list_where method. In this example, n equal greater than n%2 equals 0 is a lambda expression used to filter even numbers from a list. Lambda expressions can also be used to simplify event handlers or inline actions. Here, printMessage is a lambda that prints a message, and add is a lambda that adds two numbers. Lambdas are powerful tools for writing concise and flexible code. Use them to simplify your code and improve readability. Let's dive into delegates in C# and see how they allow us to pass methods as parameters and handle events. A delegate is a type that represents a reference to a method. It allows methods to be passed as parameters and invoked dynamically. Here's the basic syntax to define and use a delegate. In this example, message handler is a delegate type that matches the displayMessage method signature. We instantiate the delegate and invoke it to call the method. Delegates can be used with multiple methods. Here's how you can chain delegates. Here, the notify delegate is used to call both notifyBmail and notifyBisms methods in sequence. Delegates are often used for event handling. Here's an example of a simple event system using delegates. In this example, the publisher class uses a delegate event to notify subscribers with a message. Delegates provide a powerful way to pass methods and handle events. Implement them to enhance flexibility and modularity in your applications. Discover how events in C# can help you build dynamic and interactive applications by enabling components to communicate. Events in C# are a way to provide notifications to other parts of your application when something happens. They are based on delegates and are used to implement the observer pattern. Here's how to declare and raise an event. In this example, notifyEventHandler is a delegate that defines the signature of the event. The publisher class has an event notify and a method raceEvent to trigger the event. To handle events, you need to subscribe to them and define an event handler method. In this example, subscriber defines the onNotify method, which is subscribed to the notify event of the publisher. When raceEvent is called, onNotify is executed. Events are useful for decoupling components. For instance, in a UI application, you might use events to handle user actions like button clicks. Here, the button class has a click event that is triggered when the button is clicked. Events in C# provide a powerful way to handle dynamic interactions in your applications. Use them to build flexible and maintainable code. Explore how to effectively use collections in C# like list and dictionary to manage and manipulate data. A list is a dynamic array that can grow in size. It provides various methods to add, remove, and manipulate elements. In this example, we create a list, add elements to it, remove an element, and then iterate through the list. A dictionary is a collection of key value pairs, where each key is unique and maps to a value. Here, we create a dictionary, add key value pairs, access and remove elements, and check for the existence of a key. Lists offer powerful methods for data manipulation, like sorting and finding elements. This example demonstrates sorting a list and finding an element based on a condition. Dictionaries are great for fast lookups and can also handle complex operations like value modification. Here, we update a value in the dictionary and iterate through all key value pairs. Using collections like list and dictionary can greatly simplify data management in your C# application. Leverage these tools for efficient data handling. Discover how LINQ in C# allows you to write concise, readable queries to retrieve and manipulate data from collections. LINQ, or a language-integrated query, is a powerful feature in C# that allows you to query data from collections, databases, and XML in a way similar to SQL. LINQ has two main syntaxes: query syntax and method syntax. Let's start with the query syntax, which is similar to SQL. Here we use LINQ to select even numbers from a list. The from, where, and select keywords define the query. Alternatively, LINQ can be written using method syntax, which is more common in functional programming. In method syntax, we use lambda expressions to filter data. In this case, we use where to find even numbers. LINQ can be used with any collection, such as lists or arrays. Let's extend our example to find the sum of even numbers. This shows how LINQ can make data manipulation easy with methods like sum. LINQ simplifies working with data by providing a flexible, SQL-like querying experience in C#. Start using LINQ to write more readable and efficient code. Learn how to filter and sort data in C# using LINQ for efficient data management in your applications. LINQ's where method allows you to filter data from collections based on a condition. Let's filter a list of numbers to find only the odd ones. We're using the where method to filter out odd numbers from the list. LINQ's orderB sorts your data in ascending order, while orderByDescending sorts in descending order. Here, we first sort the numbers in ascending order with orderB, and then in descending order with orderByDescending. LINQ allows you to combine filtering and sorting. Let's filter for odd numbers and then sort them in descending order. In this example, we use both where and orderByDescending to filter odd numbers and sort them in descending order. With LINQ, filtering and sorting data is straightforward and efficient. Apply these techniques to manage your data more effectively in C#. Learn how to use anonymous types in C# to simplify your code and create flexible data structures. Anonymous types in C# allow you to create lightweight objects without explicitly defining a class. They're great for temporary data storage or passing data between methods. Let's create an anonymous type with a few properties. Here, we define a person object with two properties, name and age. C# automatically infers the type. Once you have an anonymous type, you can access its properties like any other object. You can easily retrieve the properties using the dot notation. Anonymous types are especially useful when you need to return complex data without creating a full class. For instance, in LINQ queries, you can project data into anonymous types. In this LINQ query, we create an anonymous type with number and square properties, which makes it easy to work with the result. Anonymous types are a powerful tool in C# for quick, flexible data structures. Use them to simplify your code when defining a full class isn't necessary. Want to group multiple values together without creating a class? Learn how to use tuples in C# to simplify your data handling. A tuple is a lightweight data structure in C# that allows you to group multiple values of different types into a single object without creating a class. Create a tuple that holds a name, age, and email address. This tuple holds 3 different pieces of data. We access the values using item 1, item 2, and so on. You can easily access tuple elements by their position. This lets you access each item in the tuple with item 1, item 2, and item 3. To make your code more readable, you can name the tuple element. Now you can refer to the tuple elements by their names, which makes the code much clearer. Tuples are a great way to group multiple values together without the need for complex data structure. Use them to simplify your code and make it more readable. Looking for a cleaner way to write conditional logic in C#? Learn how to use pattern matching for more expressive and readable code. Pattern matching in C# allows you to test an object structure or type in a simple, readable way, improving the clarity of conditional logic. Let's start with pattern matching using the is keyword to check types and extract values. Here we check if data is an integer, and if it is, we extract the value into number. Pattern matching also works great in switch expressions, making them cleaner and more powerful. In this example, we use pattern matching in a switch expression to identify the shape and extract its properties. Let's take it further with property patterns and positional patterns for complex objects. Here we match the properties of an object and extract them in one line. Pattern matching in C# simplifies conditional logic and makes your code more expressive. Use it to write cleaner, more readable code. Need to work with dates and times in your C# applications? Learn how to use the powerful datetime structure to handle all your date and time needs. Let's start by creating a datetime object representing the current date and time. You can use datetime now to get the current system date and time. Next, let's format the datetime object into a more readable string format. You can format dates and times in various ways using standard or custom format strings. Now, let's see how to convert a string into a datetime object using datetime parse. With datetime parse, you can convert a date string into a datetime object. Datetime also allows you to perform arithmetic operations like adding or subtracting days, months, or years. You can easily add or subtract days, months, or years from a datetime object using addDays, addMonths, or addYears. Using datetime in C# gives you powerful tools for handling dates and times in your applications. Make sure to use these techniques to format, parse, and manipulate date and time data with ease. Need to calculate time intervals or manipulate dates in C#? Learn how to use timespan and datetime to perform powerful date and time calculations. Timespan represents a time interval or duration like hours, minutes, or days, making it useful for performing calculations with time. Let's create a timespan object that represents a duration of 2 hours, 30 minutes, and 15 seconds. You can specify hours, minutes, and seconds directly when creating a timespan. Now, let's manipulate datetime by adding and subtracting a timespan. Here, we added and subtracted a timespan to calculate future and past times. Timespan is also useful for finding the difference between two datetime objects. In this example, we calculate the number of days between two dates using the total days property of timespan. Timespan and datetime manipulation in C# gives you flexibility for handling time intervals and date calculations. Use them to make your date and time logic more powerful. Want to simplify your code and make it more readable? Learn how to use enums in C# to define a set of named constants. An enum in C# is a way to define a set of named constants, improving code clarity by replacing magic numbers with meaningful names. Let's create an enum representing different user roles in a system. Here we define user role with 4 possible values: admin, moderator, user, and guest. Now let's use this enum in a method that checks user permission. This method checks the user role and prints whether access is granted or denied. Enums are backed by integers, so you can convert between enum values and their underlying integers. Here we convert userRoleAdmin to its underlying integer value and back from an integer to an enum value. Enums in C# improve code readability and are a great way to represent a set of related constants. Use them to make your code more meaningful and less error-prone. Curious about value types in C#? In this video, we'll learn about structs, an important C# feature for defining lightweight data structures. A struct in C# is a value type, meaning it holds data directly rather than referencing it like classes. Structs are useful for small, immutable data structures. Let's create a struct representing a 2D point on a grid. Here, we define a point struct with 2 fields, x and y, and a constructor to initialize them. Now, let's create and use an instance of our point struct. Unlike classes classes, structs are stored on the stack and are passed by value, meaning each copy of a struct is independent. Structs differ from classes in several ways. Structs are value types stored on the stack and are usually used for small, lightweight objects. Classes are reference types stored on the heap and better suited for more complex objects. As you can see, when we copy a struct, the original value remains unchanged. Structs are great for representing small, simple data types where performance is critical. Use them wisely to improve the efficiency of your C# applications. Want to add new functionality to existing classes in C# without modifying them? In this video, we'll learn about extension methods and how they can make your code more flexible. An extension method allows you to add new methods to existing types without altering their source code. It's a great way to extend functionality while keeping your code organized. Let's create an extension method to reverse a string. Extension methods are defined as static methods in a static class, with the keyword this preceding the type you want to extend. Here we define an extension method reverse a string for the string type. Now we can call our extension method as if it's a method of the string class. As you can see, the reverse a string method is now available on any string instance, just like a built-in method. Extension methods can be especially useful for simplifying complex logic. Let's say we want to add an extension method to the int type that checks if a number is even. This method adds new functionality to the int type without modifying it. Extension methods are a powerful way to extend existing types without inheritance or modification. Use them to keep your code clean and reusable. Want to write more flexible and type-safe code in C#? Learn about generics and how they can help you create reusable components. Generics allow you to define classes, methods, and interfaces with placeholders for the data types they operate on. This means you can create code that works with any data type while ensuring type safety. Let's create a generic class for a simple container that can hold any type of data. Here, T is a placeholder for the data type. We can create a box instance for different types, like int or string. Now, let's define a generic method that swaps two elements in an array. This method works with any data type, making it very flexible and reusable. Generics are commonly used in collections like list or dictionary, where you need to handle data of various types while maintaining type safety. Using generics with collections ensures that only the specified data type can be stored, reducing runtime errors. Generics in C# help you write more versatile and type-safe code. Use them to create reusable components that can work with any data type while maintaining type safety. Want to learn how to read from and write to files in C#? This video will guide you through the essentials of file I/O operations. First, let's see how to read text from a file. We'll use file readdle text for simplicity. This reads the entire content of example.txt into a string variable. Alternatively, use stream reader for more control. Here, we read the file line by line using a stream reader. To write text to a file, you can use file writle text. This writes new content to example.txt, replacing any existing content. Alternatively, use StreamWriter to write line by line. This writes a line to the file using StreamWriter. For more control, you might want to read and write files line by line. Reading line by line, writing line by line. File operations can throw exceptions, so always handle them using try-catch. This ensures your program handles errors gracefully. File I/O in C# allows you to manage file operations effectively. Use these methods to read from and write to files, and remember to handle exceptions to keep your code robust. Want to write responsive and efficient code in C#? Learn about async and await for asynchronous programming. Asynchronous programming allows your application to perform tasks in the background, keeping the user interface responsive and efficient. To create an asynchronous method, use the async keyword and return a task or task of T. The await keyword is used to wait for the completion of the task, allowing other code to run in the meantime. Here's a simple example of using async and await to perform a time-consuming operation. This example simulates a data fetch operation which runs asynchronously without blocking the main thread. Handle exceptions in asynchronous methods using try-catch blocks. This ensures that errors are properly caught and handled even in asynchronous operations. Async and await make your code more responsive and efficient by handling tasks asynchronously. Incorporate these techniques into your projects to improve performance. Want to improve your application's performance with concurrent operations? Learn how to use tasks and parallel programming in C#. A task represents an asynchronous operation. It's used to perform work in the background and helps manage concurrency. Create and run tasks using task run. You can also run multiple tasks in parallel and wait for them all to complete using task winnow. Use parallel link, plink for parallel data processing. It allows you to process collections in parallel. This example filters even numbers from an array using parallel processing. Ensure thread safety by avoiding shared mutable state. Use thread-safe collections and synchronization mechanisms when needed. Be cautious with parallelism. Not all operations benefit from parallel execution. Tasks in parallel programming in C# can significantly boost your application's performance. Apply these techniques to handle multiple operations efficiently.